Alright, so the question is, a sample contains 3.01 times 10 to the power 23 molecules of methane. What is the mass of the sample? So we're given the relative atomic mass of carbon to be 12 and the relative atomic mass of hydrogen to be 1. Again, the question is, a sample contains 3.01 times 10 to the power 23 molecules of methane. What is the mass of the sample? So what we're looking for is the mass of the sample that contains 3.01 times 10 raised to the power 23 molecules. Alright, so how do we go about this? So the first thing that you should know is that 1 mole of a substance is equal to Avogadro's number. Alright, 1 mole of a substance is equal to Avogadro's number. So 1 mole of methane is equal to 6.02 times 10 raised to the power 23, which is the Avogadro's number. Alright, so 1 mole of methane is equal to 6.02 times 10 raised to the power 23 molecules. Alright, then what is the relative molecular mass of methane? So this is methane, CH4. So the relative molecular mass of methane will be equal to C plus what? H4. So the relative atomic mass of carbon is 12. So that is 12 plus the relative atomic mass of hydrogen is 1. So 1 times 4. Alright, so this will be 12 plus 1 times 4 will give us what? 4. 12 plus 4 will give us what? 16 grams. So 1 mole of methane is equal to 16 grams. So if 1 mole of methane is equal to 6.02 times 10 to the power 23 molecules, 1 mole of methane, which is also equal to 16 grams of methane, because 1 mole of methane is equal to 16 grams from our calculation here. So 16 grams of methane is equal to 6.02 times 10 to the power 23 molecules. Alright, so if I should rearrange this expression, if I say 16 grams is equal to 6.02 times 10 to the power 23, 6.02 times 10 to the power 23 molecules is equal to 16 grams. This and this are the same. Alright, I just decided to write this first. So if 6.02 times 10 to the power 23 molecules of methane is equal to 16 grams of methane, then 3.01 times 10 to the power 23 molecules will be equal to X. You don't know. Alright, that is what we are looking for. So you want to kind of do a cross multiplication here. Alright, so when you do a cross multiplication, your X times 6.02 times 10 to the power 23, when you multiply that, that will give you 6.02 times 10 to the power 23x. Then 16 times 3.01 times 10 to the power 23 will be equal to 48.16 times 10 to the power 23 molecules. Alright? Okay. So you now have 6.02 times 10 to the power 23x is equal to 48.16 times 10 to the power 23. So the next thing that you would want to do is to divide both sides of the equation by the coefficient of x to make this x stand alone. So your x will be equal to 48.16 times 10 to the power 23 divided by what? 6.02 times 10 to the power 23. So when you divide this, you are going to have what? 8 grams. Alright? This 10 to the power 23 will cancel out this 10 to the power 23. Alright? Then 48.16 divided by 6.02 will give you what? 8 grams. So this is our answer to this question. Alright? It's a simple and a straightforward question. So that makes option B the correct answer to this question.